For countless generations, humanity has pondered a profound question. Are we truly alone in the vast expanse of the universe? Though it has remained unanswered for centuries, the rise of advanced artificial intelligence might finally offer a breakthrough. Recent developments suggest that Google's AI has detected peculiar transmissions from deep space, signals so refined and distinct that they seem to align with nearly every benchmark scientists have established for potential extraterrestrial communication. Remarkably, these signals had gone unnoticed for years, concealed amidst enormous data streams, until AI meticulously analyzed them and brought them to light. Could this be the definitive sign we've been waiting for? The revolutionary discovery involved 8 separate radio transmissions in 2023, all of which raised eyebrows across the scientific community. These weren't just random disruptions in space noise. They were pinpoint narrow-frequency signals that manifested only when astronomers aimed telescopes at specific celestial bodies, disappearing completely the moment those telescopes turned away. What made the finding even more astonishing was how these transmissions had previously slipped through the cracks, despite countless hours of human analysis. It took an AI system digging into an enormous 150 terabyte data archive gathered by the Breakthrough Listen initiative to finally detect them. For perspective, that's equivalent to analyzing over 30,000 high-definition movies. These mysterious signals ticked all the crucial boxes that SETI scientists typically use to identify potential alien transmissions. 1. Directional consistency. They surfaced only when instruments focused on designated star systems and vanished otherwise, a pattern indicative of a non-terrestrial source. 2. Tight frequency range. The signals often span just a few hertz, an extreme precision rarely found in nature. Most astronomical sources, like stars and pulsars, emit signals over much broader ranges. 3. Doppler drift. The signal showed a slight frequency shift over time, suggesting the source is in motion, possibly rotating or orbiting, similar to what we might expect from a planetary transmitter. Interestingly, the system responsible for this remarkable detection wasn't developed by a leading scientist, but by Peter Ma, a University of Toronto student. He designed a deep learning algorithm based on Google's TensorFlow framework. His neural network picked up what traditional data sifting methods had completely overlooked. The same AI was later utilized to reevaluate years of astronomical records many believed had already been thoroughly examined. To scientists' shock, it uncovered previously undetected signals in a 2017 dataset involving 820 nearby stars. Researchers at the Breakthrough Listen project, a leading initiative aimed at discovering intelligent extraterrestrial life, adopted this AI system to reclassify signals once discarded as irrelevant noise. This marks a monumental shift in the field of extraterrestrial intelligence research. Historically, the search for life beyond Earth has been constrained by the limitations of human-designed detection methods, algorithms that may have unintentionally ignored critical clues due to their rigidity. Now, by turning over the reins to artificial intelligence, researchers are finding new doors swinging open. The AI doesn't just analyze data, it interprets it in novel ways, revealing clues the human mind would never detect. The role of AI in SETI has revolutionized the process of searching the stars. Before, trying to detect extraterrestrial transmissions was akin to seeking a grain of sand on an endless cosmic beach. The major obstacle: we don't even know what this grain truly looks like. AI has drastically redefined this hunt. Now, scientists employ robust machine learning systems to sift through astronomical petabytes, millions upon millions of gigabytes of radio data, seeking even the faintest anomalies that could indicate intelligent origin. These algorithms go beyond just speed. They function with an entirely different strategy. While older systems look for fixed, predefined signatures, AI is capable of recognizing nuanced deviations and unfamiliar linkages within the data. It can distinguish authentic deep space signals from earthbound interference, such as emissions from cell phones, orbiting satellites, or radar equipment, with accuracy never seen before. The SETI Institute has now integrated these AI systems directly into their radio telescopes, enabling real-time signal evaluation on a scale that was once science fiction. Streams of observational data now pass continuously through these neural networks, which evolve with each new dataset, refining their ability to detect possible signs of intelligence. According to astronomer Cherry Ng from the University of Toronto, who helped develop the AI that located those 8 historic signals, this technology doesn't claim that what we detected is definitively alien. Instead, it helps scientists apply a more calculated method to assess the likelihood of such phenomena. Although follow-up attempts to detect those same signals again were unsuccessful, a crucial step for verification. The mere fact they were flagged by AI proves that this technology may permanently reshape how we explore the universe. Moreover, AI's contribution isn't limited to flagging strange signals. It's also fostering entirely new conceptual frameworks for imagining alien technology. Instead of basing our search solely on human logic, machine learning enables the identification of entirely foreign patterns, ones that might be completely outside the realm of current human speculation. The metaphor of finding a needle in a cosmic haystack remains apt, but the haystack now spans across the observable universe, and the needle might be something humans wouldn't even recognize if they saw it. This is where AI's unprejudiced lens becomes invaluable. SETI teams now utilize highly advanced machine learning systems influenced by technologies from industry leaders like Google and NVIDIA. These models don't just replicate human pattern recognition, they surpass it. Conventional algorithms are bound by human design templates, but AI excels at discovering anomalies and patterns that break the mold. This is essential, considering that any extraterrestrial civilization may use technologies far beyond our comprehension. AI filters through torrents of earthly interference, like military radar, satellite chatter, or radio emissions, to find a rare signal that might genuinely originate from stars. These systems are constantly learning. Every new piece of data enhances their understanding of what constitutes ordinary cosmic phenomena versus what could be extraordinary. The scale of their computational reach is mind-boggling. Today's AI-powered SETI systems analyze more data in 24 hours than traditional searches did across multiple decades. As quantum computing matures, these already powerful capabilities are poised to expand exponentially. Perhaps the most compelling trait AI brings to this pursuit is its lack of bias. Human scientists naturally focus on signals that mirror our own communications, such as narrowband radio emissions or structured light pulses. But AI isn't restricted by these expectations. It detects anything that statistically stands out from the backdrop, even if it doesn't resemble anything familiar. This flexibility is likely our best bet at identifying civilizations thousands, even millions, of years ahead of us. Beyond the realm of SETI, AI is propelling numerous space research efforts forward. In 2017, for instance, Google's AI made headlines after helping NASA identify Kepler-90I, a planet orbiting a distant sun, making that solar system match our own in planet count. Remarkably, this world had been missed by astronomers in prior reviews. Chris Xiaoyu, a Google AI engineer, developed a neural network trained to detect minuscule dips in brightness as planets cross their stars, signals far too subtle for earlier systems to catch reliably. This success inspired another collaboration in 2019 between Google and the University of Texas at Austin, which led to the discovery of 2 more previously hidden exoplanets buried within Kepler's later mission data. The AI had uncovered them hiding in plain sight. In perhaps the most dramatic example, Google's TensorFlow framework was applied in 2018 to reveal 72 previously undetected fast radio bursts, FRBs, from a repeating source known as FRB 121102. Initially, scientists had only spotted 21 such bursts from that object. The AI tripled this figure, transforming it into the most data-rich FRB source ever recorded. These achievements underscore how AI is not just complementing research, it's taking the lead. By discerning patterns invisible to human perception and making cross-references across vast, multidimensional data arrays, AI is setting new standards in observational science. Instruments like the James Webb Space Telescope, arguably humanity's most advanced space observatory, now rely on machine learning to isolate significant signals from their enormous datasets. Everything from pinpointing faint galaxies to interpreting atmospheric signatures of exoplanets now requires AI input. This evolving partnership between human intuition and machine cognition is opening entirely new portals of cosmic understanding. Each data cycle enriches these neural systems further, enabling them to improve at distinguishing between noise and potential insight. While the 8 signals flagged in 2023 certainly drew worldwide attention, even more powerful AI tools have since taken their place in monitoring the heavens. In New Mexico, the Very Large Array, one of Earth's premier radio telescopes, has been augmented with a real-time AI system dubbed Sidecar, capable of analyzing an astonishing 2 terabytes of data.